In this video, we're going to take a look at aldehydes and ketones. They're a family of organic molecules that contain C and H, in addition to a functional group known as the carbonyl group, which is C double bond O. So aldehydes and ketones both contain the carbonyl group, which is a C double bond O. What determines whether you're an aldehyde or a ketone is where this carbonyl group is placed. So if the carbonyl group is placed at the end of a molecule, so at an extremity, then you have an aldehyde. But if the carbonyl group is placed at somewhere in the middle of the molecule, then you have a ketone. So that would look something like this. If you had an aldehyde, you'd have a carbon chain, and then you'd have your carbon double bond O. And since your carbon double bond O is at the end of the molecule, it must be connected to an H. So that would be for your aldehyde. Whereas if you had a ketone, you'd have R, which is a carbon chain, C double bond O, and on the other side, another carbon chain. Sometimes you put the prime here to indicate that carbon chain is, a different length than the one on this side over here. Doesn't really matter; they could be the same length. But the point is that this carbonyl group is at somewhere in the middle. Whereas for a ketone, whereas for an aldehyde, the carbonyl group is somewhere at one of the ends. So, what are the general formulas? Well, for aldehydes and ketones, they have the same general formula: CnH2nO. And if you had cyclic, just take away two hydrogens for that for that connection to be made to make that cyclic compound. So here we have the carbonyl group. Here we can see the aldehyde with the C double bond O at an end, therefore it's attached to an H. And then here we can see the ketones, where the C double bond O is somewhere in the middle and of a carbon chain. So here's the carbonyl group. Here's carbon chain on the left. Here's carbon chain on the right. Same thing over here. Same thing over here. But this prime again indicates a different carbon chain length than the one on the left. So your first step before naming aldehydes and ketones is to be able to identify what you're dealing with. So if I were you, I would try to pause the video and classify the molecules below as aldehydes or ketones, and then unpause it, check that you're on the right track. Let's start with something a little bit easy first. We'll start with this one over here. This one's pretty straightforward. You'll notice the C double bond O has an H connected to it. So that means that this carbonyl group is at the end of a molecule. It's not anywhere in the middle. So this is considered an aldehyde. Here, let's go to this one over here. Also fairly straightforward. Your C double bond O is somewhere in the middle. It's not at the end over here. It's not at the end over here. It's not at the end here or here. It's in the middle of the carbon chain. So this would be an R group over here, and this would be the other R group over here, R prime, let's call it. So because this is somewhere in the middle, we have a ketone. So now with bond line diagrams, it can be a bit confusing, but it's really not that much more difficult. This C double bond O is on a carbon that's at the end. You don't see the H, but there really is an H here as well that you don't see. It's just that with bond line diagrams, we often don't represent H's. We just know they're there. So because this is at the end of a molecule, this is the aldehyde. This C double bond O is in a cyclical molecule. If you have a cyclical molecule, you don't really have ends. This is technically in the middle of a molecule. So this would make this a ketone. So if you're able to identify aldehydes versus ketones and know how they're different from the other functional groups we've seen so far, then you're ready to go start naming aldehydes and ketones. The rules are written side by side because they're very similar. There are some differences, and we'll go over those differences together. Before we go into the rules, just a couple things to start talking about now. We have to discuss the idea that some functional groups have priorities. So if a molecule contains many functional groups, let's go take a look at this example here. This contains a carbonyl functional group and an alcohol functional group. And it's not carboxyl because they're separated from each other. This is the hydroxyl functional group and the carbonyl functional group. So what do we classify this molecule as? Is it a ketone or is it an alcohol? So you have to understand your priorities. The aldehydes and ketones, they have higher priority than the alcohol. So if those two functional groups are together, the carbonyl group and the alcohol group, the hydroxyl group, then the aldehydes, ketones win. They have higher priority. That's a rule that you need to remember. The priority list can be found in your functional group table over here. So you'll notice highest priority is with the carboxylic acids, and then it goes down from there with aldehydes being slightly above ketones, followed by alcohols, amines, double triple bonds, and then everything else after that in alphabetical order. So so far, this will be our highest priority functional group that we're dealing with because it's higher than alcohols. So let's go over some of the rules together. We'll name this molecule and discuss the rules as we name it. So when you're naming an aldehyde, I know this is an aldehyde because the double bond O is at the end. You have to start numbering from the end that contains your carbonyl group to give it the lowest possible number. So we have 1, 2, 3, 4, 5, 6, 7, 8. And of course, you want to get the longest possible chain in there. If there's many chains that you could choose from, you always want to get your aldehyde functional group in there, your carbonyl group in there. But then if there's other paths, like choose the one with highest priority groups in it. So for example, if there's a path with only single bonds and a path to double bonds, and choose the one with the double bonds as your parent chain. But for now, it's not going to be an issue. For now, we're just going to focus with purely an aldehyde. So we have 8 carbons. And on carbon number 3, there's a methyl group. So we have 3 methyl. And then since we have 8 carbons, it's octan. And for aldehydes, the ending is al, al. You don't have to put a number to indicate where the aldehyde group is, because when it comes to the aldehyde group or the carbonyl group for aldehydes, it's always at carbon number 1. It's always going to be at one of the ends. So there's no point in putting a 1 there. It's implied that it's there. So that's 3-methyl octanal. So you list substituents the same way. The only difference is really the ending and then where you start counting from, and it's from the carbonyl functional group. Next, we'll do an example of a ketone. So as you can see here, we have a carbonyl group in the middle of a chain somewhere. So we have to choose our longest parent chain that contains that carbonyl group. And it looks like it's going to be this one over here. And so when we take a look at this, we have to start counting from the end that gives the lowest number possible to our carbonyl group. And so it looks like we can count from here: 1, 2, 3, 4, 5, 6, 7. So we have a 7 carbon chain. Now, because this double bond O could really be in multiple areas and not just a carbon 1 or this carbon over here, which would be carbon 1, because it can be, here, 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 here. We have to actually indicate where that carbonyl group is located, and I'll show you that in just a minute. For now, let's just take a look if we have any substituents. We do. We have one on carbon number 3. This is a propyl group, but it's connected on the second carbon, so it's an isopropyl group. So we have 3 isopropyl. And then we have 7 carbons, so heptan. And then because the double bond O is on carbon number 2, we have heptan 2, and then in ONE for ketones. So you do have to indicate for ketones, unlike aldehydes, where the C double bond O is. And so that is our example of how to name a ketone. So before we go do more practice problems with drawings and naming, I want to go over this one here where you have multiple functional groups and just talk about priority in a bit more detail. So remember that we're talking about the carbonyl group having higher priority than the alcohol. So this would be considered a ketone in this case. This is a ketone molecule as opposed to an alcohol. And so our ending will follow the rules for ketone naming. But what do we do with this alcohol group? How do we indicate it? Well, if it's a lower priority now, it now is treated as a substituent. And so when the alcohol is treated as a substituent, its name is hydroxy. Not hydroxyl, but hydroxy. If it was an amine like that, its name would be amino. So we have 1, 2, 3, 4. That was done because we want to give the lower number to the higher priority. You'd like to give the lower number to both, but if you went the other way, the ketone would have a very high number compared to what it could have here. So our hydroxy group is on carbon number 4. So we have 4 hydroxy, and it's a butan 2-one. Butan 2-one. So So in this video, we saw the difference between aldehydes and ketones. They contain carbonyl groups, and what really differentiates one from the other is where that carbonyl group is located, whether it's at the end, being an aldehyde, or somewhere in the middle, being ketone. That's important to be able to identify in your molecules before you can actually go and name them. When we're dealing with aldehydes and ketones, they have pretty high priorities, or higher than alcohols, amines, and a bunch of other stuff. But they're not the highest. There are other things that are higher than them that we have not seen yet. The rules for naming aldehydes and ketones were discussed, and they're very similar to each other, but there are some key differences, so please make sure that you understand them. And then please make sure that you go over the priorities to understand that when you have something high priority and something low priority, the lower priority one becomes a substituent and has a substituent name, such as hydroxy for the hydroxyl group or amino for the amine group. In the next video, we'll do some more practice problems related to naming and drawing aldehydes and ketones.